Yeah, but simple ones. All right, here we go, guys. So limits. What is a limit? What does it mean to find a limit? Let's start with looking at the notation. So this notation here, guys, the way you read it, here's how you read it. Limit as x approaches some number c of the function f of x is equal to whatever it equals, L. And that's how you read it. Every now and then, they'll have a little symbol on the upper left-hand corner, like a little minus sign. So when you see that, limit as x approaches some number c from the left-hand side of this function f of x is equal to, and that means from the left, that you're approaching from left. Child, what do you mean? Don't worry, we're going to talk about it. If you see a little plus symbol on the upper right-hand corner, that means you're approaching from the right. Notice it has an X with an arrow, so that means as the X value approaches from the right. Does that make sense, guys? And what you're looking at, see it says here, I put it here in bold, you're pretty much, a limit is a Y value which a function approaches as X approaches some value. That's all it is. So, and then we're going to talk about continuity and all that good stuff, but we're not there yet. We'll talk about all that details next week. So here we go. We're going to start basic. By now, I hope that we know how this function more or less looks like. You don't have to be perfect, but we should have an idea of how it looks like, at least the basic rational functions. Just by looking at it, so let's talk, because we've been doing rational functions for a while now. So I have this function, and I'm going to write it 2x squared plus 5x minus 3 over x squared minus 9. And the first thing I'm going to do is, can I find my horizontal asymptote without much thinking? Yeah, my horizontal asymptote is what? Y equals 2. Because, man, I should have changed the 2's. Too many 2's everywhere. I should have made it a 3 or something. Because the highest degree in the numerator is 2, the highest degree in the denominator is 2. That is not why the horizontal asymptote is 2. It just so happens it's a 2. So you take the coefficient in front of the x squared in the numerator, the coefficient in front of the x squared in the denominator. 2 divided by 1 is 2, so that's my horizontal asymptote. That's my end behavior as I approach positive infinity and negative infinity. So horizontal asymptote is that. Next, vertical asymptotes. Well, to find the vertical asymptotes, you got to see your factors. So let's see. My factors of the numerator. There's only one way. I'm going to do the guess and check method because this one's pretty easy. There's only one way to get 2x squared, and that's 2x times x. There's only one way to get a negative 3. Either 1 times 3 or 3 times 1. Obviously, opposite signs. Notice that it has to add up to a 5. Because this is negative, I'm looking for the difference of the product. Chop, what are you talking about? So let me see. Let me get it wrong on purpose. 3 here, 1 here. I got it wrong on purpose, so don't write this down. So I'm looking for the difference. See, that's a 2x. That's a 1. So I'm going to multiply the variable by the constant there. 2x times 1 is a 2x. 3 times x is a 3x. And some of you might say, Chop, 3x plus 2x is 5x. That's the answer. Be careful. The product is a negative 3 here. This times this has to be a negative 3, so that means the signs are opposite, so that means I'm looking at the difference. So the difference between 3x and 2x is 1x. Do you guys see that? So that's a 1x, it cannot be that. So obviously this is the correct one now. I'm going to move the 3 here and the 1 there. So check it out. 1 times x is 1x, 2x times 3 is 6x. The difference between 6x and 1x is 5x. Do you guys see that? And I want it to be a positive, so I make the bigger number the plus. Plus, minus. Over, the bottom is the difference of squares. X plus 3, x minus 3. Was that explanation clear, guys? Okay. Next, I see a factor. X plus 3's cancel out. So that means I have a vertical asymptote wherever I get a 0 in the denominator, whatever you have left. So vertical asymptote. And I usually abbreviate it, so my bad if I'm not. X equals 3. Hey, Norma. You can come in, you can come in. Does that make sense, guys? All right, next. Where's my hole? The hole is located at x equals negative 3. And all I got to do is plug in negative 3 into whatever I have left. 2 times negative 3 minus 1. That's in the numerator. All over negative 3 minus 3. So let's see. 2 times negative 3 is negative 6, minus 1 is negative 7. Negative 3 minus 3 is negative 6. Negative divided by negative is a positive, so you have a hole at negative 3 comma 7, 6. And there it is. Horizontal asymptote, vertical asymptote. Check out the picture. Horizontal asymptote, y equals 2. Vertical asymptote, x equals 3. Whole, negative 3,76. How do you get your behavior to be positive infinity as you approach 3 from the right? I want to make sure that you guys understand this is not the only way. You could also use the calculator, but to find this behavior, hopefully you understand this when I say this. And sorry guys, I didn't get much sleep and I have so many ideas in my head that I want to get out, but how do I get it out precisely? All right, here's what I'm trying to say. As you get closer and closer to 3, your x value, the delta x becomes practically 0 as you get closer and closer to 3, but you can't divide by 0. Hold on, guys. Yes, sir. Okay. Here we go. You guys ready? If I were to plug in numbers closer and closer to 3, notice that the denominator would get smaller and smaller. Child, what are you talking about? If I plug in a 3.1, this will turn into 0.1. If I plug in a 3.01, this will turn into 0.01. If I plug in a 3.001, this will turn into 0.001. Do you guys see that? So, and then the top number, you're just going to get some value. 2 times 3 minus 1 to 6. You're going to get something close to 5. So what I'm trying to say is this. Look, I'm going to keep it simple for now. 1 divided by 1, 1. 1 divided by 0.1, 10. 1 divided by 0.01, 100. 1 divided by 0.001, 1,000. 1 divided by 0.0001, 10,000. Do you see what's happening? Here's another way that you can see it better. Let me plug in this calculator here. Oh, Boston, they asked you for you in the counselors. Sorry, I just forgot. Oh my God. No, I didn't forget. I wanted you to see that, but now we're good. Education's important, miss. Don't be mad. All right, here we go. Apps. Hold on. All right, sorry guys. Give me the equation that I had on y1, or on y1. On what was it? My original one, 2x squared plus 5x minus 3. What did I? And in the bottom I had x squared minus 9. All right, check it out, guys. This is what I'm talking about. Look what's happening. Look what's happening. I made my table blank. Look what's happening as I get closer and closer to 3. If I push 3, I'm going to get an error. You can't divide by 0. If I push 3.1, look at the y value, 52. If I put 3.01, 502. 3.001, 5002. 3.0001, 50,002. Do you see how the y value is just exploding? So that's what I wanted you guys to make sure that as I approach my vertical asymptotes, I'm either going to be approaching positive infinity or negative infinity. Those are the only 2 ways that you can go if you approach vertical asymptotes. Cool or not cool? Cool. All right, I think we're good. Sorry. Yes. I just wanted you guys to know the behavior as you approach a vertical asymptote. That you either approach positive infinity or negative infinity. The difference. The separation between the asymptote and the function gets closer and closer to 0. Yeah, but you'll never be 0 because you're undefined at 3. But yeah, okay. Here we go. Go to the next page. I put the graph up there. Here's where the magic happens. You're going to love it. You're going to love it. Look how simple this is. You guys ready? All right, so you guys tell me. As x approaches negative infinity, the graph of f of x approaches what? Say it again? No, the y value. 2. Put a 2 in there. How do I write this with limit notation? Like this. Limit as x approaches negative infinity of this function, f of x, equals 2. Don't worry, we're going to have many chances to try. All right, let's look at the graph. It says they give me a statement. As x approaches positive infinity, the graph of f of x approaches. If I approach positive infinity, it looks like I'm approaching that end behavior again. What's that end behavior? 2. So my y value approaches 2 again. So let's see. Help me out. So what do I write for limit notation? I write the word lim, which is like limit. And I put in the bottom, I write x with an arrowhead. And I'm going to write positive infinity. And then I either write the expression or I write f of x. I'm going to write f of x. And all this is approaching what value? 2. How do we feel so far? Cool. Look at this next one. As x approaches negative 3 from the left. Okay, so here's negative 3. And I'm approaching from the left. Notice there's a hole. But I'm still approaching that y value, even though it's a hole. It's just discontinuous. We'll talk more about that later on. That hole is at negative 3,76. If I approach from the left, that y value is approaching 7,6. So how do I write it? Like this. Limit as x approaches. Okay, what happened? I heard someone say what. Okay, what am I approaching, guys? But from what direction? From the left. So I put negative 3 and I put a minus sign on the upper right-hand side. That means from left of f of x equals, and what does it equal? 7,6. As x approaches negative 3 from the right, so that means I'm approaching, so here's my graph. I'm approaching negative 3 from the right. So, what is this? What is the y value? What am I converging at? 7,6. It's converging at that hole. 7,6. Maybe I shouldn't use that word yet. Limit as x approaches negative 3 from the right. How do I say it from the right? Plus symbol on the upper right-hand corner of f of x equals 7,6. Do you guys know who Lindsay Lohan is? Have you guys seen? Yeah, have you ever heard about the movie called Mean Girls? Do you remember? Okay. There's a part in that movie where she's in a math contest and she's talking all this mumbo jumbo, and then she says a famous quote. Do you guys remember that quote? Okay, let me tell you what she's talking about. You see how on these two situations I'm approaching from the left and the right, but I'm approaching the same number, but from the left and the right? If you approach the same y value, the limit exists, and the limit is just that number. But here's the Lindsay Lohan. If this were approaching 7,6 and the one on the right was approaching a different number than 7,6, then they wouldn't match. And because they do not match, then you would say the limit does not exist. That's the Lindsay Lohan deal. Does that make sense? So look at this one. It says as x approaches negative 3, just like the ones before, but it doesn't say from left or right. So that means they have to agree. So the graph of f of x approaches 7,6 because it approaches it both from the left and the right. So then I just write limit as x approaches negative 3, and you don't put anything on the upper right hand corner. That means you approach left and right, and it does in fact equal 7,6. Are we okay so far? All right. Now check this one out. As x approaches 3 from the left, so now I'm approaching 3, which is my vertical asymptote. If I approach 3 from the left, what am I approaching? If I approach 3 from the left, my y values are not 0. Negative what? Negative infinity. Negative infinity. So I'll write limit as x approaches 3 from the left, upper right hand corner, put a minus sign of f of x. And, well, okay. I'll go ahead and tell you because it's a technical issue. So don't give this a thumbs down, guys, if you math nerds are out there. You can never equal negative infinity, so that's a technicality. So some people just say limit as x approaches negative 3 from the left of f of x does not exist, or the behavior is negative infinity. But this is fine for now. Equals negative infinity. So we're good. Cool or not cool? All right. Here we go. Go to the next one. Turn the page. Yeah, next time I'll make the smart follower, or next time I'll put the graph here. Limit as x approaches 3 from the right. So I go back to my graph. If I approach 3 from the right, what am I approaching? What am I approaching? Tell me, guys. You can come in. You can come in. Guys, what am I approaching if I approach positive infinity? Positive infinity. So put positive infinity right here, guys. So then write, what am I going to write? LIM, limit, as x approaches 3 from what side? So put a plus symbol on the upper right-hand corner of f of x equals infinity. Are we okay? All right, let's see. Let's see if we got it, guys. Look at this. Limit as x approaches 3. Doesn't say left or right of the graph of f of x. Okay, well, if I approach from the left, all right, guys, focus. If I approach from the left, you guys told me negative infinity. If I approach from the right, you guys told me infinity. Am I approaching the same thing? So what am I going to say? Does not exist. Does not exist. So here we go. Limit as x approaches 3 of f of x does not exist. Some mathematicians will tell you that you should not be having an equal sign. I guess for now I'm okay with that. But when you get to your professors, don't write equals, just say the limit does not exist. Hey, what's up? Yeah, I'm doing my mock test. Oh, sorry, I thought you were going to give me that.
I just wanted to make sure so I can tell the...
Yeah, I would like to test the calculus kids in, is it Babin? Grajero's old room? Mm-hmm. In Babin's room, and then I'm going to test everyone else in either Valderas or Weersburg, and then I'm going to have my room open for pizza during lunchtime.
Okay, so it's going to be Weersburg. Mm-hmm. Therefore, we know what's open and things like that.
Perfect.
Yeah, thank you so much, sir.
Mm-hmm. All right, are we cool, guys? All right. All this is saying right here is what we just said. Right. All right, guys, focus. All this is saying right here is what we just said a little while ago. In order for the limit to exist, the left side has to match the right side. If the left side matches the right side, then you can just write it as a single limit like that, and it equals that value. That's all that little formula says. If the left side does not equal the right side, does my limit exist? Not at that value if you don't put the plus or minus symbol. Does that make sense? Don't worry, we're going to practice. We're going to practice a whole bunch. All right, we have a picture. We're going to practice. I'm going to start with letter A. Limit as x approaches -1, and it has a plus symbol, so that means from what direction? The right. There's only one way to approach. So here we go. X approaches -1. All right, guys, focus, Sanchez. I'm approaching -1 from the right-hand side. What's that y value? 1. That's the only way you can approach. There's only one direction. That's the domain. That's an endpoint. All right, letter B. Here we go. X approaches 1 from what direction? So I go to the curve. X approaches 1 from the left. What is this value? The y value? 2. You have a hole, but I'm still approaching that value. So I'm approaching 2. Do you guys see that? All right, let's go to the next one. Letter C. As x approaches 1 from the right. I'm approaching from the right. What is this y value? 1. I heard someone say 1. Unless, no, you said 1, right? Okay, but there it is. All right, now notice letter D. It doesn't have a plus or a minus. It just says 1. Do I approach the same y value from the left and from the right? No, look. From the left, I approach 2. You told me right here. From the right, I approach 1. Do I approach the same y value? So then the limit does not exist. Does that make sense? I need to approach the same y value, Kambiru. See, from the left, I approach the value 2. From the right, I approach the value 1. I'm approaching. Yeah. Look. Okay. Limit as x approaches 1 from the left. Here I am. As I approach 1 from the left, I'm approaching 2. Limit as x approaches 1 from the right. Look, here's from the right. Okay. Letter E. All right, guys. Letter E. Limit as x approaches 2 from the left. I'm approaching this removable discontinuity, but I'm still approaching that value. What is it? 1. Actually, it just says limit as x approaches 2. If I approach 2 from the right, it's also 1. It matches, so that's my limit. Cool or not cool? All right, letter F. Limit as x approaches 3 from the left. So that's the only direction I can come from. If I approach 3 from the left, what is it? 1. Letter G. It doesn't say the word limit. So this just wants to know f of 2. What is it? That's not 1. I have a point way up here. That's where you're defined. That's where this function is defined. F of 2 equals 2. It doesn't say the word limit. It just wants to know f of 2. Does that make sense, guys? What's up? No, this is a point, and remember that's a whole. So when the value is 2, when the x value is 2, what's my y value? Well, it's not 1 because there's a hole there. My y value is right there. Which one? Letter what? E? Oh, I'm approaching 2 from the left and the right. So I'm looking, because it says the word limit, I'm just approaching the x value of 2. What is my y value? Like, see? So, and they both approach the same y value. I have a hole there, but I'm still approaching it from both directions, that y value. Cool? Cool. All right. Check it out. Don't worry. You're gonna feel better after we do some of this. All right. Go to the next page. Yeah, all it is where you are approaching, guys. Next page. You're gonna like it. You're gonna like it after this. I think you'll get it better. All right, guys. Focus, real quick. Don't worry. I know you guys are beasts, but focus. All right. Look at this. It says limit as x approaches a positive 3 from the left. So I'm looking at 3 x value here, and I go to my curve. If I approach x equals 3 on that curve, the y value is approaching what? Yeah, I heard someone say it. Say it out loud. It says say space. What is it? 1. There it is. 1. All right, here we go. Limit as x approaches 3. What does that plus symbol mean? From the right. So I go to the curve and I approach 3 from the right. If I approach 3 from the right, what is this y value? 3. Yes, it's a hole, but it's not asking about the function. It's saying, well, it is, but it's saying the word limit in front. All right. Limit as x approaches 3. So I check. Does it agree? From the left, it's 1. From the right, it's 3. Does the y values agree? Or do the y values agree? They don't. So you're going to say what? Does not exist. The limit does not exist. Okay, here's where a lot of kids get confused because they tell me does not exist. Okay, be careful. The function exists. This is a function. Look, it says graph of f. But f of 3, so I'm looking for a point. Okay, guys, everyone focus. I'm looking for a point at 3. I have a hole. Do you see anywhere, is there a point anywhere at x equals 3? Do you see a point anywhere? So you're going to say, you don't say the word does not exist, you're going to say it's undefined. You're going to say undefined. It's not in there. There's no y value for that x. And it doesn't say the word limit. Does that make sense, guys? Okay, Hannah, you doing okay? Okay. All right, here we go. Now this one's a little kind of hard sometimes, but I think the more experience you get, the easier it gets. It says find all values or determine all values of a for which the limit as x approaches a of this function equals 0. So here's the best way to tackle it. I go to the picture, I go to the graph, and I look for where this function is 0. It's 0 there. It looks like it approaches 0 at 2. And it approaches 0 at 8 from both directions. I do not say 7 because 7 just approaches from one side. And this, it needs to match both. Child, what are you talking about? Here it is. I'm going to write them. Limit as x approaches -5 of this function. We would call that a 0. See? If I approach from the left, it's 0. If I approach from the right, it's 0. So from there, you can say that a equals -5. Limit as x approaches 2 of this function is 0. So from that, I would say that a equals 2. Limit as x approaches 8 of this function also equals 0. That's a semicolon, so I would say that a equals 8. I do not use 7 because that one only works if you approach from one direction. So we don't use a equals 7 since, no, you just say, you don't have to write, this is just for notes. We don't use a equals 7 since you can only approach 7 from left. Must match from left and right, not just left. Does that make sense, guys? Okay. Don't worry, guys. We're almost done. All right. I would like for you guys to get super beasts that you can do this without having to graph. But I've noticed throughout the years that almost all of you guys are visual learners. And I understand. I'm a visual learner too. It's hard to see abstract things. It's always easier when you just, here's a picture. Here's what's happening. So let's draw what's happening. Look, check it out. I did this on purpose. All of these are linear lines. All of them. So you don't have to think much. This is called piecewise. It behaves like negative x plus 1 between 0 and 1. It behaves like 1 between 1 and 2. This one here is a point. X equals 2, 2, so that's just a point. It behaves like x minus 1 between 2 and 3. It behaves like negative x plus 5 between 3 and 4. Chop, how am I going to draw this? I don't know how I'm going to draw it. Like this. Focus, guys, focus. At 0, this has a y-intercept of 1. And at 1, negative 1 plus 1 is 0, but that's going to be a hole. So hole, and I just connect the lines, or the points. Well, I guess technically that's not a point, right, because it's a hole. So do that. Yeah. All right. I'm going to answer why I did what I did. It only behaves like negative x plus 1 between 0 and 1. I know that that's just a linear line that goes like this forever. But between 0 and 1, I behave like negative x plus 1. So y-intercept of 1, slope of negative 1. Or you can just plug in a 0 in here to tell me the where I'm at specific values. And it's a linear line, so you just connect them. Does that make sense or no? No? All right. Okay, I think it'll make sense once I do the second piece. Watch. Because that one's simple. Don't worry, guys. Look. Yeah, look, you're going to see it. Once you see this, you're going to see it. This behaves like 1 only between 1 and 2. Does that make sense? It's a piecewise. So I go to 1, the y value. I put a solid right here. And I go all the way to 2 with a circle, and I connect those. And now, I think this will be easier to explain. Okay. Between 0 and 1, I behave like negative x plus 1. So here is negative x plus 1 only between 0 and 1. Between 1 and 2, the output is a 1. So here is a 1 between x value 1 and 2. This is called piecewise. Yes. Okay. All right. Real quick. Y equals negative x plus 1. Does everyone know how that graph looks without a calculator? Oh, okay. No, it's okay. It's okay. Without a calculator, guys, this one is a y-intercept. Ortiz, guys. This is a slope of negative 1. And this graph would look like this forever. Yes or no? Now, I'm not telling you about this slope forever. This line forever. I want this line, but only between 0 and 1. And notice that the 1 does not have an equal sign. So at 0, whatever y value that is, and at 1, open circle, because I cannot include that x-intercept. Does that make sense, guys? All right, I continue. At 2, I'm at 2, so I'm going to put a point at 2, 2. I'm going to say here's 2, put a point. 2, 2. Because that just says equals. It's not an interval. And then it tells me between 2 and 3. And remember, these are all linear lines. Like, Chop, how am I supposed to know how this looks? Just plug in a 2. 2 minus 1 is 1, so that means I'm back here down here. And then if I plug in a 3, so let me put a 3 here. If I plug in a 3, 3 minus 1 is 2, so I'm up here, and there's an equal sign on the 3, so there it is, solid. And I connect them. Does everyone see how I got that? Yeah, I'll say it again. Here's how I got it, guys. All of this circle thing, just use, remember, math is the easiest subject in the world. It really is. Guys, all you're doing, look, when x is 2, look, they're telling me the interval between 2 and 3. They're all linear lines. When x is 2, plug in a 2. 2 minus 1 is 1. Oh, okay. At 2, I'm going to start there. There's no equal sign, so don't fill it in. At 3, 3 minus 1 is 2. Oh, look, there's an equal sign on 3. So I go to 3, and I put a point at 3, 2. And that's where I'm going to be at. And then I say, oh, I got to go from here to here. I guess I'm just going to connect them. Straight line, because it's linear. Yes, we're going to do it again right now. Check it out. Look at my next interval between 3 and 4. Do you guys see that? At 3, notice there's no hole. I mean, there's no hole. There's no solid. There's no equal sign. So you just go to 3. Negative 3 plus 5 is 2. So at 3, I'm going to start right there at that solid one. So that you already got the point. At 4, negative 4 plus 5, 1. So go to 4, 1. Yeah, I'm going to come over here. Look, guys. Look, guys. This is my interval, guys. This is my interval. At 4, I plug in a 4 in here. That negative stays there. Negative 4 plus 5 is 1. So the output is 1, and there's an equal sign down there. So I have a point at 4, 1. I need to go from this point, which was 3, 2, all the way to 4, 1. So it's a linear line. There it is. Yes.
So in the second to last one, it's saying that 3, 2 is like a solid dot, and the second one isn't it kind of implying that it's a hole?
Yeah, but it doesn't matter because that solid dot and that hole are in the same location, so it looks like it's a nice continuous curve. Yeah. Ask me another question. Yes.
How do you know it's a hole for 2, 1 and 1, 0?
Because at 2, 1, I do not have an equal sign. See? There's no equal sign. Give me another question, guys. Did you guys cover piecewise functions in Algebra 2? Okay. All right, not a big deal. The concept's pretty straightforward. It's okay. All right, here we go, guys. Let's see if we can answer these questions. Letter B, I'm going left to right. As x approaches 0 from the right side, that's the only location you can approach. If I approach 0 from the right, what's the y value? 1. If I approach x equals 0 from the right, you're approaching the y value of 1. Limit as x approaches 1 from the left. If I approach 1 from the left, if x approaches 1 from the left, what's my y value? 0. If x approaches 1 from the right, what's your y value? 1. Limit as x approaches 1. Do they both agree? So you're going to say does not exist. Limit as x approaches 2 from the left. 1. Limit as x approaches 2 from the right. 1. Limit as x approaches 2. 1. Limit as x approaches 3 from the left. 2. Limit as x approaches 3 from the right. 2. Limit as x approaches 3. 2. Limit as x approaches 4 from the left. 1. That's the only direction you can approach. F of 2. 2. Doesn't say the word limit. That means when x is 2, what's the y value? I see a point at 2, 2, so that's the y value. Cool or not cool? Don't worry, guys. Don't worry. We're almost done. There's the last one, and it's really simple. Don't look outside. Don't look outside. All right, here we go. Look how simple this is, guys. You guys, focus, focus, focus. We need to be able to do this without a calculator. We need to be able to do this without a calculator, and it should be pretty simple for you guys. Even if piecewise, even if this is the first time you've seen piecewise, you by now should already start seeing how it's not that bad. So what this is telling me, it's telling me that I behave like x squared plus 1 between negative 2 and 2. That I behave at x equals 2, my y value is a 1, that's a point because it's not an interval. And that between 2 and 8, I behave like 5. Does everyone know how x squared plus 1 looks like? Yeah, it's just a parabola with a vertex at 0, 1. So look at it, check it out. Negative 2 squared is 4. 4 plus 1 is 5. So I'm going to say this is 5. So it looks like this. And let me see. Closed circle here and open circle on that one. It's supposed to be symmetric on the... Let me do it better. There we go. Cool or not cool? All right. At 0, 1, my y-intercept. Next. Don't worry, guys. Don't worry. We'll be fine. At x equals 2, the y value is 1. So I'm going to put a point at 2, 1. Next, between 2 and 8, my y values are always what? 5. So I'm going to say 8. I'm going to say 8 is way over here. And look, it looks like this. Open circle at 8. Do you see how we did it? And then I'm just going to say, look, so let's see. If you can do this much, you're winning. What is the limit of f of x as x approaches 2? Tell me how to write it with limit notation. I write what? LIM. What do I put below it? X arrow towards 2, and then I write f of x, and then I put equals what? 5. Do we understand that? Then you'll don't worry, relax. I have a delta, but it's over this. And I put, if you can't get it done today, I put 99% credit for Sunday if you can't do it today. So 1 point difference is not going to make a difference in your average, I promise you. But if you can do it during advisory, it's only 10 minutes worth. And that's it. That's all I got.